What is up? Daniel here with the Virtual Robotics Studio, and we are back for the moment you've probably been waiting for if you didn't skip ahead to this video already. We're going to do our driver control mode or our teleop, so it's time to get out your gamepads. But before we get started programming, special thanks to First and Argosy Foundation for making this all possible. Okay, so you will need at least one controller, if not two. I'm using these are like the Logitech F310s. I think you get these in the kit of parts, so most people probably have these. You can also use an Xbox controller or a PlayStation controller, or really any joysticks. Anything will work. I recommend sticking to the gamepads. Gamepads are nice because you can kind of move around. A lot of times, one of the problems for the drivers is they can't see what's going on. And with the gamepad, you can walk a little bit one way or the other to get a better view. If you have joysticks on the table, you're a little more anchored to them. But ultimately, whatever your driver is comfortable with, whatever they like the best, is the right choice. OK, so let's open back up our software. Just in case you have yours closed, chances are, if you rerun the 2024 WPI Lab VS Code, it will open right up to the code where you left off. But if it doesn't and it's closed, I closed mine intentionally for this, we're going to do File, Open Folder, and then on the desktop, I have 2024 code, 2024 FRC Kitbot. That's the folder I want, so I say Select Folder, and then it opens everything back up. And I think it even goes right back to the line where we left off. OK, but this is all auto, and we are not doing autonomous mode here. And here's something interesting. You can actually, like next to this line, public void autonomous periodic, if you go next to it, there's actually a little caret to make it like, contract so you don't have to see all the extra lines of code. So just so we're not jumping over all of that long autonomous, I'm actually going to click on that so we can get down to our teleop easier. I'll leave the other stuff in, but that'll make it a little easier for us to jump back and forth. And this is one of the reasons why command-based code eventually might be the way you want to go. Because as we have all of our different auto modes all together here, like so we did 3 autonomous modes, but you're going to have more and more and more and more and more. And I forgot to label these, so you probably wanted to label those steps. But you're going to have what, like maybe 6 auto modes, 5 auto modes. So that's just a lot of lines to look through. So sometimes it's nice when it's organized differently, but it's going to work. OK, let's go all the way to the top. And we are missing one thing on our import to be able to use our gamepads, and that is importing the gamepads. So I'm going to do import edu.wpi .first.wpi lab j. And here is where you choose. If you're using either the Logitech or an Xbox controller, we're going to do Xbox controller here. So Xbox controller, there it is. Sometimes, like, I don't know if you've noticed this, but sometimes, like, if it doesn't show up, deleting the dot, redoing the dot, and typing it again makes it show up. So that's a good troubleshooting step for VS Code. All right, so if you're using an Xbox controller, do Xbox controller. If you're going to use a PlayStation controller, you can do PS4 controller or PS5 controller. Those both exist here as options. And if you're using none of them, you can do joystick. And joystick works, but you have to figure out specifically what every button is. So like when you do, let's change it back to Xbox controller because that's what I think most of us have. Or the Logitech is an Xbox. It mimics an Xbox controller. If I run my driver station, which you might as well do too, and turn your robot on as well. If you are using joystick, what you actually have to do here is go to this USB tab, the USB tab, and let me go ahead and plug one of my gamepads in. So I'm going to just take one of these gamepads, plug it into whatever USB port you have available. And you can now see I have controller 0 showing up on my thing here. And basically, we can now go through and move stuff on the gamepad and see it move on this list. So if I press like the A button on the gamepad here, you can see the very top button box lights up. That means this is button number 1. If I press the B button, it's button number 2. Then we have X and Y. You have the right bumpers. You have the positional hat. It actually, if you push down on the joysticks, those are buttons too. We have start and select. So we have all these different buttons that you can be hitting. Also, if I move the joysticks, you can see the axes list will move accordingly. So up and down here seems to be axes. I can't remember if it's 0 or 1 because I don't know if, so this one that moves first, I don't know if that's 0 or 1. So this one could be 1 or 2 and so on down our line here. So if you're using a custom joystick, then in the code, you use joystick and you'll have to go into that driver station to find out which button it is. But if you're using an Xbox or a PlayStation controller or our Logitech, the button labels, like the A button, is just called A button. So that's going to make our life easier. So we're going to do Xbox controller. Oh, there is one more very important thing on this controller that I have to point out. So one of the things that can cause you problems is if this mode button gets pressed. You see how that little light lights up? So it's off and it's on. So that mode button, if that light is on, it makes this joystick not work. Instead, it makes this positional buttons up here work. So that's really bad. You always need to make sure that that light is off when you're using these joysticks or gamepads. And on the back, you'll notice there's a switch. And the switch has X on one side and D on the other. The X stands for Xbox. That makes it work like an Xbox controller. The D stands for direct input. So that one will work a little bit differently. So make sure that you are on X and make sure that that light stays off the entire time we are using these gamepads. Okay, let's get back to the code. So we imported the Xbox controller, so we can use them now. Now down here we have to make our specific Xbox controllers. So I'm going to go under timer. Doesn't really matter where, but it's our whole long list of private finals that are here. We're going to do a private final Xbox controller. And we're going to name them. We have 2 controllers. Now, typically what teams do, and you don't have to do this, but typically what teams do is they will have one driver whose only job it is to drive the base of the robot, to do the drivetrain of the robot and move it into position. Then you'll have another controller who we usually call an operator. So usually you have the driver and the operator. The operator is responsible for everything else on the robot. So they'll have to hit a button to be able to load notes in. They'll maybe hit another button to launch the note. Maybe we even change the speed at which we launch the note. So maybe there's a way you can lower the speed enough to get it to go into the amplifier instead of the speaker. That's something that you might want to play with. So having somebody else control all of those other things means the driver doesn't have to be super dexterous moving and hitting like a bunch of buttons at the same time. So that's how people usually split it out. This robot's pretty simple, so if you only had one driver, you could probably put everything on the same gamepad. But if you add anything, if you add a hanger to this robot, if you find a way to do floor pickup, if you find a way to, well, I guess those are the 2 big things that I think would add. There's the other thing that you can score the one at the end, right, for bonus points when you're going up as well. But if you're adding any additional systems, that just adds more complexity and more things for a person to control, and that's more reason to split to 2 drivers. Of course, it does mean they're going to have to practice and they're going to have to communicate well. All right, let's go back here. So we have Xbox controller. So what I'm saying is I'm going to have one called driver, and then we can call it controller. Sure. Driver controller equals, and this is going to be a new Xbox controller. So now we have an Xbox controller that we can use. Oh, and it is not happy because I skipped something. Xbox controller does need the open and close parentheses, and what you put inside is the port that it's plugged into. And by that, I mean on here, like we have 0, 1, 2, 3, 4, 5. So our driver one is in 0 right now. So that's cool. But you can drag these around. So if I want the driver to be in 5, I can drag it down there and now it's in 5. Or I can drag it back up to 0. I don't remember if there's a way to get rid of the missing ones. But you can rescan if they're not showing up. OK, so 0 is the driver one. So here, inside the parentheses, we're going to put a 0. Then we'll hit enter, do the same line of code except for our operator. So private final, Xbox controller. This is going to be our operator controller, or you could do op controller. equals new Xbox controller. And I think in the new, if I picked it, it puts the parentheses for me. So that's what I was saying earlier. Sometimes, or in the last video, sometimes it puts the parentheses, sometimes it doesn't. Let's do this one in port 1. Might as well just use 0 and 1, and then get our semicolon. All right, now we're going to scroll down all the way to teleop periodic. Okay, and remember, autonomous is still here. It's just closed up, so don't forget you still got that. You might want to expand that before you're done today. And in teleop periodic, what are we going to do? So now we have to do all of the things that we did in autonomous mode, but kind of set them up for driver control. And I think the obvious place to start is our drivetrain. So let's do, we called it my drive dot. And there are two different ways we can control the drivetrain. So we'll just go ahead and try both of them really quickly. And I recommend you try them both as well, because maybe you like one more than the other, and you won't know unless you actually test them out. So one way is called tank drive. That's what we were using in autonomous mode, where you specifically tell the left wheel what power it gets and the right wheel what power it gets. The way to think about that is the left joystick, forwards and backwards, would control the left wheels forward and backwards. The right joystick, forward and backwards, would control the right wheels forward and backwards. So we could drive forward by pushing forward on both of them, go backwards by pulling backwards on both of them, or turn by going forwards on one and backwards on the other. So that is tank style steering. Then we have arcade drive. Arcade drive, forward and backwards on the left joystick makes the entire robot go forward and backwards. And left and right on the right joystick makes the robot rotate left and right. That one, I think it's called arcade drive because it more closely resembles how playing like a first or third person game on console would work. So usually you do forward, backwards on one, and then the right joystick, you can look up and down. We don't have that, but left and right as well. So a lot of people, a lot of high school students especially, are more comfortable with arcade style if they play a lot of video games. But if they drive like a high-low or a skid steer, they probably want tank drive. And everybody's different, and there's no right answer. So it's whatever your driver is more comfortable with is the best thing for your team. So over here, we're going to do my drive dot. Let's do tank drive first. So I'm going to do tank drive. And now, what does it want? It wants left speed and right speed inside here, not this kdefault period stuff, which it always guesses wrong for tank drive. Now, in autonomous mode, we just put numbers, right? Like 0.5, comma, 0.5. But if we do that here, there is no way to actually control the speed. No. We don't want to pick a specific number to go inside here. We want to read a value from our gamepad and use that to control the tank drive. So as it turns out, this joystick, if you move it all the way, if you don't touch it, it's a 0. It sends 0 to the computer. If you pull it all the way one way, I think down, it sends a 1. And if you push it all the way forward, it sends a -1. And if you push it halfway, it's going to send you like a 0.5. That's perfect. That's exactly the numbers we need to send to our motor, except, I don't know if you caught this, it's backwards. Pushing forwards is negative, and going backwards is positive. It's a long story, but essentially the problem is video games. It's because computer screens, you start on line 1, and so moving down on the screen is positive because there is no negative. Anyway, what that means is, in our code, we're going to read the value from our gamepad. So we're going to do the name of the gamepad, which is driver controller dot get left, and we want left y, because left y is up and down, x is side to side. So this is going to get our left y value for our controller, but we can't just put get left y. It's backwards, and I know it's backwards because these gamepads are always backwards, so we're going to just put a negative sign here. And the negative sign is basically the same thing as saying, hey, you could do -1 times this, right? So whatever that number is, it's now negative of that. So that solves our backwardsness. Then we're going to do the same thing on the other side. So a negative driver controller dot get, but this time it is going to be right y. As I said, the left stick controls the left drive, the right stick controls the right drive. That is what we're doing here. And guess what? We're done programming the drive of our robot. So let's go ahead and hit our W here. Deploy robot code. If you have not already, make sure you're connected to your robot's wireless network. That is the #1 reason for an error at this point. If it doesn't go, you might still be connected to your wireless. So make sure your robot's turned on, make sure you're connected to the network, and then it should connect through. All right, we can load up our driver station here. We don't really need this dashboard anymore because it's auto choices. So we just need our driver station. And make sure your controller is in 0. And when you press buttons on it, it should light up. I don't know why the things over here disappeared. That's weird. But we don't need them right now, so I'm not going to worry about it. But you can see as I press buttons, it flashes here. So I know that I'm controlling it with 0. When you have 2 of them plugged in, that's a good way to figure out which one's which. Also, labeling them doesn't hurt. All right, let's go to our control here. And we're going to go teleoperated mode. And every time we do new code, the first thing I'm going to do is be ready to press disable, because weird things could happen. If it moves at all before I pick up the controller, I'm going to disable it. It did not. OK, so now I'm going to pick up the controller. I'm going to go for that left joystick forward. So the tendency here is to just go crazy, to pick up the controller and just start going for it. What you want to do is test things one at a time. OK, so remember, our robot, let's turn it this way. So this is the front, this is the back, this is the left side, that's the right side. So we're going to do left side first. All I'm going to do is push the left joystick forward a little bit. We should see the robot drive forward away from the camera here. And only the left side should move. That was right. Now I'm going to go backwards on the left side. Make sure that works. Good. And so what we verified here is that the left joystick is controlling the left side of our robot, and forwards is forward and backwards is backwards. If it's not, you have to flip your signs or you have to flip your .gets so that they're correct. Now let's do the right side. I'm going to push gently forward on the right joystick. Yep, that's forward. And backwards. Yep, that's backwards. So now we verified the right side is set up correctly. Now I can try to push forward on both to drive forward. I can go backwards on both to go backwards. And we can go forward on one and backwards on the other one to turn. Now, I don't know if you're getting this completely from the camera, but this robot, especially when it's light like this, has got a pretty good amount of acceleration. It's going to jump around. It is a fast-moving robot. That's great when we want to drive a long distance, like to cross the whole field. That's not so great if I need to drive over here and line up at the goal so I'm shooting in the right place. I have to be very gentle on those gamepads to get kind of parked in the right spot and aimed to be able to launch in there. So something that a lot of teams do, and we're going to go ahead and add this code just so that you have an example of it, is we can scale down the speed of the driving so you're not always at full speed. We can make it so that maybe you're limited to half speed. But before we do that, we'll go ahead and bring this kind of back to where we were. So we're ready to go. This is where normally I would have to get up and move the robot when we were doing auto mode. But now, since we're doing teleoperated mode, I can just drive it back to where I want it to be. All right, I'm going to disable the robot. Let's try arcade drive. So we did tank drive. Now we're going to try arcade drive. And I'm going to leave tank drive in my code so I can switch back and forth anytime I want. I'm just going to do 2 forward slashes. So that is now commented out. We can go back to that anytime we want. Next line, though. Let's do a new my drive. Dot. This time, we choose arcade drive, which is the first option. So that's cool. And arcade drive wants to know our speed and our turn. I did not mean to drag that around. So our speed is not going to change. Our speed is still left Y. So driver controller dot get left Y. And it's negative, right? We learned from before that should be negative, comma, and then our turn, our rotation value is going to be driver controller dot get right, this time X, get right X, because we want it to be the side to side for turning. Okay? And I don't know if the X-axis is flipped or not. So let's try this. And if it turns the wrong way, we'll know what we have to come in and fix. So hit the W. Let's deploy our robot code. Let that run for a second. And again, we're going to test stuff methodically as soon as this comes up. So we'll see if forward and backwards work. Then we'll see if turning right works and turning left works. And we'll know, kind of what the issues are if there are any. So let's load this up. We're going to go teleoperated and enable. And it didn't move. I'm always ready to hit disable if needed. OK, so on the gamepad now, I'm going to go straight forward on the left joystick. The robot should drive straight forward. Yeah, OK, if we go backwards, it should drive straight backwards. Okay, so our left stick is working correctly, our speed of the robot. Now, I'm going to try to turn to the right. So let's see if it turns to the right when I go right. Okay, that was left. Let's turn to the left, and that was right. So it's working, but it's backwards. So let's go back to the code and make a change. Disable your robot. And all that means is, when I said I wasn't sure if the right X should be flipped or not, it should be flipped. So that's going to be a negative for right X. And we're going to just deploy, and then we'll test it again. All right, get the driver station up. We will go teleoperated enabled, and let's see what happens. So now I'm going to try to turn to the right again. And that is now right. And that is now left. So now I have the ability to drive, and I can use them both at the same time as we're driving here. Right? So I'm just holding forward on one, but turning and moving at the same time is possible. Although it is very fast for the small amount of space I have here. And you'll probably find that too. You know, if you're moving some furniture in a classroom to be able to do this, it's going to feel very fast for the size that you have available to you. But the actual first field is 54 feet by 27 feet. So you got pretty long runs there where you will want your robot to move very fast. OK. So that's working. Let's go back and let's do that thing that I said where we can maybe slow it down so we have fine control some of the time. And the way we're going to do that is by adding a variable. If you imagine, if I took the value from our left Y stick, that's a number between -1 and 1. If I multiplied that by 0.5, now it would no longer be a number between -1 and 1. It would be a number between -0.5 and 0.5, which means we are limiting our top speed to half in either direction. But if we do a 0.5, we can never change it. Instead, we want to tie it to some control on the gamepad. So let's scroll all the way up to where all the private finals are. And this is a good place to kind of create our variables too that we're going to use. So I'm going to create a new variable here. And when we create a variable, we start out with the type that it is. And if you remember from the autonomous video, integer or int is a whole number. We want to be able to use decimals, so we're going to do double here. And it's not going to be a final, because we're going to want this number to change as we're using it. So we're just going to do double, and let's call this drive limit equals, and we'll start it at 1. OK, if we go back down now to our teleop section here, teleop periodic, I want to be above my output line here. This is the output. This is where we actually send values to the motor. And what we want to do here is say, hey, look, if in this line of code, what if we multiplied by our drive limit variable? Well, right now it's a 1, which means we go full speed. And we need to put that on both of these. OK, so right now it's a 1. But what if we had a way to change the value of drive limit? So sometimes it was 1 and we could go full speed. And sometimes it was 0.5 and we could only go half speed. Well, that's what we're going to do now. So I'm going to scroll over, make sure you have times drive limit and the semicolon. That's going to go off the edge of my screen here. The line above where we actually set our stuff. And if you're doing tank drive, you'll have to add this to tank drive for it to work. What we can do is we can say, hey, if. What if we check to see if a button was pressed? And as a driver, so like when I'm holding the controller, your thumbs are kind of on the joysticks to drive around, which means like hitting the X, Y, A, and B buttons, you have to stop controlling the robot to be able to press those buttons. So I think the best buttons to use for this, or anything that you want the driver to control while they're driving around, are these top buttons here on the side, which are called bumpers, or the bottom ones, which are triggers. And I like the bumpers more because the bottom ones are actually analog. You got to pull them a bit more. The top ones just, I don't know, they click nicely. So I'm going to use the top two buttons. I'm going to make it say, hey, if we hit the right button, full speed. If we hit the left button, half speed. So that's what we want to read in here. So if we do the name of our controller, right, which was drive controller dot, we can do get, and I'm looking for right bumper. That's the right side button on top. The bottom was called right trigger. So right bumper. And this bumper is a Boolean value. It's either true or false. So really, we're good. Right now, this is saying if that button is pressed, run this code. You can think of it this way. This is like the explicit way of writing it. We can say equals equals true. So if the button is being pressed, then go here. But since the value from the button is already true or false, you don't need to do the equals equals true. And we need to do equals equals because when you do the 1 equals sign, like we did up here, that is saying take this value and store it in our variable named drive limit. So if we did a single equals down here, that would be like saying take the value true and save it in our controller button value. And that doesn't work. So double equals is when you want to compare two things. Single equals is when you want to store something or save something in a variable. All right, so we've got our, if it's true, then we want to change our drive limit to equal to 1. So I like the right side being full speed. Then we can do another line. Basically, we're going to repeat the code we did. We're going to say else if driver controller dot get left bumper. And we're not going to do the equals equals true this time because it's not needed. Because again, it is true or false. Then drive limit equals 0.5. So now, if you press the right bumper, it's 1. So we multiply our gamepad values by 1 down here. So we're full power. And if we hit the left bumper, now it's 0.5. So now we scale everything down by half. So we're going half speed. Now, 1 is the most that you can do. If you try to send more than 1 to a motor, it's already full speed. So you can't, there's no turbo by making this, by making this a 2. You can't get super turbo mode or whatever. All right, so we have 1 and 0.5. Let's test it. That should give us that control. So we're going to deploy our code here. And get our driver station ready. So I'm on teleoperated. Looks like our code is running. So let's enable it. OK, and now here's what we want to see is if I start driving, it should be full speed because we started at 1. So yep, that still jumps around and spins crazy fast. Now I'm going to hit that left bumper button, and we should be going half speed. So this is full power forward, but that is not nearly as fast as it was going before. And in fact, I can spin at the slower speed. Now I'm going to hit the right bumper to go up to full speed and left bumper to go back down to half speed. So we know that it's working. And you can see now, if I'm at half speed and I'm over here trying to do my fine adjustment, that's way easier for me to aim and get set up over here. And then I can hit full speed and rip across the field to go get another note so we can do it again. And now we can go slow so I don't crash into cameras or the table. All right. That, I think, is everything we're trying to get done for our drivetrain. But we have all of the operator stuff that we have to figure out. So let's go back into our code and start thinking about our operator stuff. Now, what does the operator need to be able to do? I guess, we don't need to look at the code yet. We need to just think. Our operator needs to be able to, when we drive over to the human player and they're dropping the ring into the robot, we need to be able to hit a button that lets the ring load. We also need to be able to hit a button that will launch the ring. But launching the ring is not so simple because launching the ring means that we have to turn on the launch wheel, let it spool up, and then we can turn on the feed wheel and let it launch the rest of the way. So we need to have that timer stuff working as well. Okay, well, let's work our way through. Let's start one at a time. So we're still in teleop mode because we already created our gamepad. We already have the second gamepad up and ready for us to use. And what we need to do now is, let's see here. We're going to find a place. So where is it? We have all our drive stuff is here. So what I'm actually going to do is I'm going to label that / drivetrain code here. And then down here, I'm going to do another // and this is going to be our launcher launcher code here. And if you add more systems onto this robot, go ahead and add another section for if you have a hangar or whatever else you add on. Okay, so we have our launcher code. Now we can kind of see where we are when we jump around. And let's do loading, right? Let's try to load it in. So how do we know if we are loading? Well, we can pick a button on the operator controller. If you haven't already plugged your operator controller in, I guess now is the time. You should all have 2 gamepads. If you only have 1 gamepad, I'll show you how you can drag it back and forth. But Xbox Social popped up. No, thank you. But by having 2 plugged in, we'll just switch between the two gamepads. So this is driver. This one is my operator. And we're going to follow along with the choices that First is using in their version of the code. And so left bumper over here on the operator controller is going to be our load button. So let's go ahead and do that. So in our launcher code, well, if that button is pressed, and so that means we do operator controller dot get left bumper. So we're just reading the value from our operator controller this time. If that button is pressed, what should happen? Well, load mode means we have to be running the wheels in to take the note in from outside and suck it into the robot. So that means we're going to need to set our launch wheel to something, .set. And it's going to be a negative value. And I think we can make the launch wheel just as fast as possible, -1. That's going to give us the best chance of grabbing and sucking the note into the robot. Then we have to also do our feed wheel .set. And the feed wheel we do not want at -1 because, and we'll take a look at the robot here, when this ring gets pulled in, and it's all the way in, like the beginning is easy, right? But when it's all the way in down here, this wheel is still touching. And so if this wheel is still spinning at maximum possible speed, we're going to probably start getting some friction on here. We're going to get some burning or some friction. So that's not ideal. So this wheel can go a lot slower. So instead of -1, let's use -0.2. So 20% power on the feed wheel. Okay, we need an else case here, which is if you're pressing the button, we should be going in the negative direction. Else, right now, because we don't have any other functions, let's just turn them off. So launch wheel.set, and we're going to say 0. And feed wheel.set, and we're going to say 0. So what we've added here is code that says if you're pressing the left bumper, then set the launch wheel to spin inward at full speed, the feed wheel to spin inward at about 20% power. And if you're not pressing it, turn off. So you have to hold the button down to stay in loading mode. Okay, time to deploy and test it. Deploy robot code. And if we take a look at our driver station while that's deploying, remember on the USB tab on the side, I now have 2 controllers. If your controller's in the wrong spot, you can drag it to the right spot. If you only have 1 controller, you can drag it back and forth between the 2 spots to test both things. And my controller just disappeared. And there it is, it's back. Okay, so I'm going to put that as controller 1. So we're using 0 and 1. I don't really know why these ghost controllers are here, but whatever. So let us go to Teleop enable. And actually, so I don't have to get up because I'm a little lazy. I have the driver control, so I'm going to, let's pull over closer so I can try to feed it from where I'm sitting. Let's go that half speed mode so I can really get close without damaging anything. All right, now on our operator controller, if I hit the left bumper, we should get these wheels to start spinning inwardly. And that looks good. And if I let go, they stop. If I hold it down too, we can see, especially when I let go, we can see the bottom one stops right away. The top one takes a while to stop, which means we are getting different speeds. So let's go ahead and hold that button down. And essentially, when you load it from the human player, it's going to drop onto the shelf. And, well, there we go. So loading works. We have successfully loaded a note into the robot. Now, how do we launch it out? This one is a little bit trickier. So I'm going to disable the robot. And then we can start, well, let's think about it. There is a pattern that has to happen. It's the same pattern we did in autonomous mode, which is when you hit the launch button, it can't just turn both motors on because we won't have had enough time to spool up the motor. And I know we were launching a little short in autonomous mode, but we'll be launching way short if you just turn them on and wait no time. So every time we press a button, and I think we're going to use the A button on this gamepad. Every time we press the A button, what should happen is the launch wheel should turn on, get up to full speed. Then after about a second, we should turn on the feed wheel at full speed to launch the thing out. And then after a certain amount of time, they should turn off. So we're basically going to do our autonomous code right here in Teleop. OK, so let's take a look. We've got else. And here's the thing. In the else, we're not just going to immediately turn stuff off. We will turn it off if we're not doing anything or if we need to, but we need to check some other things first. So the first thing we want to check for is, did you press the button? If operator controller dot get a button. And remember, all these button choices that I'm doing here, A button, left bumper, whatever it is, if you don't like that button, if you think the control scheme is better by using a different button, use a different button. You want to use right bumper for the launch and left bumper for the intake? Do it. You want to use A for launch and B for intake? Do it. It's up to you. Or your driver, or your programmer. But whatever works for you is totally, totally fine. OK, so if we press the A button, what do we need to do? We need to start essentially our autonomous mode. And in autonomous mode, we used that timer to keep track of how long things were spinning. So essentially, when we press the A button, that's like us saying, hey, reset the timer. So let's do that. We're just going to do timer1 dot reset. So now we can reuse that stopwatch. When you press the A button, timer 1 goes to 0 and starts counting up. So now we can use that timer to control that for 1 second. We're going to spool up the launch wheel, then we're going to launch, then we're going to turn everything off. OK, so down here, underneath that, that's its own if. We just do this if to check and see if the A button is pressed. If so, we reset our timer. And our timer starts in robot init. If you remember, up here in robot init, we start our timer. OK, then the timer is used in autonomous mode. By the time we get to teleop periodic on the competition field, our robot will have been turned on and disabled for a long period of time. Then we would have had it reset. We would have had 15 seconds of auto mode. And then there would have been a small delay, and then it would be teleop mode, which means our timer, when we start teleoperated mode, is going to be like 15 point something seconds. That means we can use the timer. That means the timer is like some big number, right? So until we reset it, we're not going to see any small numbers. We're not going to see 0 seconds or 1 second on the timer. We're going to see 15 seconds or more. So now what we can do is we can use that timer to take us through our next set of cases, our next set of possibilities. So if timer1.get, remember .get is how we actually read the value from the timer, this is the same thing in auto mode. If it's less than 1 second, what should we do? We should turn on our launch wheel. OK, but we are now running into a little bit of an issue. And that is, you see how we have launch wheel.set here, and we have feed wheel.set, and down here we have launch wheel.set, and we have feed wheel.set. And we're about to do another launch wheel set and another feed wheel.set. And then we would have to do another one because we're going to have another case here. Well, it is very dangerous to have outputs to motors exist in multiple places. If your code is good and only one of those cases ever runs, you will not have a problem. But there is a chance that there's some bug in the code or you make a mistake and 2 of these different places will run at the same time. Well, what would happen if we were trying to turn our launch wheel on to load at -1, and we were also trying to turn our launch wheel on to launch at 1.0? We would be flickering between sending full power and negative power to the motor depending on how the code executed. We don't want that. So we really want to change our code now so that we only ever have one launch wheel.set and one feed wheel.set in the entire teleoperated period. Which means instead of doing .sets here, we're going to have to make a temporary variable to remember the value that we want to use. And then that value we can pass to our launcher at the very bottom of our code. So let's go back up to the top where we created our other variables. So scroll up until you get to all the private finals. That's in the public class robot extends. Yeah, where we did double drive limit. We need to do another double. And this is going to be our launch power equals 0. We're going to start at 0. And we're going to do a double. And this is going to be our feed power equals 0. Now, these two lines of code, you could put them here. It is also perfectly fine to put them down here at the beginning of teleop periodic. So that's kind of up to you. There are some differences in how it works in the program. I think it's a little bit less confusing to just put them all together in the same place. The drive one, the drive limit one, actually has to go up there. So that's why I'm going to put the other ones up there with it. And that's because the drive limit ones need to remember their value in between. The wheels are always going to get a power every time. So they don't need to remember their previous value. And so that means we could put it inside here. But don't worry about that. Just know that now we have to go in here. Instead of launchWheel.set, we're going to replace that line of code with launch power equals the number that's there, -1. Okay, so this line of code is now replaced with that. Then we're going to do the same thing for our feed wheel. So now it's feed power equals -0.2. And this can go away. So if our launch power and feed power are set here, and we take our, I guess we have to replace this one too. Let's replace these while we're at it, right? So right here, we're going to do launch power equals 0, and feed power equals 0. And then these two lines of code, what I actually want to do is let's copy these two lines of code, and let's cut them. Let's cut them, not just copy. Okay, so all of this is our else case right here. We want to go below that. So the last thing that happens before this closed curly brace, and that closed curly brace is what ends teleop periodic, so just before that last curly brace, this is where we want to set our launch wheel and feed wheel. And we're not going to set them to 0. We're going to set them to launch power and feed power. So what's the difference? Well, we save launch power as -1 and feed power as -2 when we're loading. And then down here, it's -1 and -0.2 that actually gets written. So there is no change to the way the code works, but now we only have one dot set, and that's a little bit better way to organize your code. So we can now get back to working on stuff. We had, if you press the A button, we reset the timer. Then if the timer's less than 1, what should be happening? Well, we need to make launch power be spooling up, so full power here. And we can leave our note here too. This is spool up the launch wheel. And what should our feed power be? Well, our feed power should still be off while we're spooling up. Okay, that's our first case. Now, next case, if timer1.get is less than, and how long do we think it takes to launch? I don't know. Let's just do 1 second of launching. So we'll do 2.0. I feel like we kept increasing that in the autonomous video, but I think we have some other things that we're going to have to tweak on our robot to get a little bit more performance out of the launcher. Okay, so if it's 2 seconds, then we want to keep our launch power on. So launch power stays at 1. Our feed power now is also 1. So full power, full power. And by the way, this has to be an else if. So first we check if less than 1 second has passed, we spool up. If we're past 1 second, since we pressed the A button, then we are now ready to turn the launcher on. So this is actually launch the note. Okay, and then finally, if more than 2 seconds have passed, we have ran it enough that now it's time to turn off the motors. So we're going to do an else case down here. And this else case is these two lines of code that we have, launch power equals 0 and feed power equals 0. So we had these from a couple steps ago. But I need to take the closed curly brace and put it after feed power. So make sure you have it in between the curly braces. OK, so let's kind of go through this line by line and try to understand everything that's happening here. So first, if the load button is pressed, nothing matters. It's going to go into load mode. If the load button is not pressed, then we can start to check. Did the A button get pressed? If it did, then we can reset our timer. And then it will say timer.get. For 1 second, we spool up our launcher. And then the next one is after 1 second, so between 1 and 2 seconds now, we turn our launcher and our feeder on. So that should actually fire the note out. And then after 2 seconds, we turn everything back off. If at any point during this launching sequence, you switch and press the load button, the loader is going to take over and we're going to go back into loading mode. So loading mode kind of has priority here. Now there's another problem, and that is if you press the A button repeatedly, it will never launch. If you press the A button and hold it down, it will never launch, because every time the A button is pressed, it is resetting our timer. We can make this a little bit better. So there's actually a different function here instead of get A button that we can use. So I'm going to delete the get A button, and I'm going to do get A button pressed. Why is it angry? Let's try doing the delete a period and pick it. There we go. I think it was missing parentheses. OK, so now the difference here between get A button and get A button pressed is this code will only run one time per A button press. So you press the A button, this runs once. If you did the other one, if you held the A button down, it would run over and over again. So now you can press and let go of the A button or hold the A button. As long as you're not tapping the A button, our timer will have a chance to count up. But again, if you think about it, if I'm sitting here tapping the A button over and over and over again, it's going to keep resetting the timer. We'll never go more than 1 second, so we'll never get to the point where it launches the note. The wheel will just be spooling up. Now, if you get into a situation where, for some reason, you need to get the wheel to spool up longer, you could actually tap the A button for a little bit to buy more time for it to spool up, and then stop tapping it, and you'll get to the point where it launches. But I think that's it. I think this code is ready to go. So let's go ahead and hit our W here. We're going to deploy robot code. We've already got a note in the robot. Looks good. We are running here. Oh, I closed everything. OK, there we go. We're going to go teleoperated enable. So let's drive kind of, right now, I guess let's just drive nowhere. Let's just launch this note. OK, so I am going to press the A button 1 time on my controller. And when I press it, the top wheel should turn on for 1 second. After 1 second, we should then launch the note. The feed wheel should turn on. So in 3, 2, 1, A button, 1 second, and launch. Didn't that? OK, first of all, that's got to be worth something. I could not do that again if I tried. Let's just take a moment and appreciate what just happened here. OK, so second of all, that looked like it shot way higher than the one in autonomous mode was shooting. So that's interesting. We might have to dig into our autonomous mode more and see if something weird is going on. But look, we pressed it. It spooled up for 1 second. It launched. That was perfect. Let's drive over. Let's get another one, and let's try again. Let's go slow mode when I'm driving towards myself. All right, so once again, we're now testing. If I press the other button, that should change it to loading mode. And in fact, if I go into launch mode, if I press A, it's spooling up. But if I go loading mode, it overrode it, and we're in loading mode now. So I can feed a note in. And then let's see if in autonomous mode or in Teleop, we have enough power right now for this to go. So we're going to line it up here, something like that. I'm going to press the A button in 3, 2, 1. 1 second to spool up and launch. OK, we're still just a little low. Felt like we had a little more power. We might need to aim our robot a little bit more back. Let's come back. I've got one more note here, so we might as well load one more. And then we can turn around. Maybe also we can kind of creep up on this side of it. So because you can get a little bit closer here to the wall. Obviously, there is a barrier there, so some of these turns maybe are not possible, but let's launch this one in 3, 2, 1. Yeah, that was good. That one almost went in. Maybe we need to tilt up on our launcher to be a little bit higher angle, but we're definitely in the ballpark. All right, so that is everything that we need to do for teleoperated mode. We can drive around, we can go fast, we can go slow. You know how to do tank mode, you know how to do arcade mode. We have loading mode on our operator joystick or controller, and we have our launch, which is the full sequence of spool up the motor, wait 1 second, and then launch the node. So that's great. There's one more thing that I have to warn you about, the way that we wrote this program, and that is if you turn your robot on and you enable it, so if you hit that teleop enable, and you do that within 2 seconds of the robot being connected, then our timer will be less than 2. So if you do that in less than 2 seconds, those wheels will turn on. So, it's very unlikely that you will get to that point on accident. It will never happen during an actual match. But just know that when you turn the robot on, if you do it too quickly, there is a chance that it will spool up and launch a note right away, which just reinforces the fact that if you were turning your robot on, people's hands should not be in it. But that said, if you spend any amount of time disabled before you click the enable button, like 2 seconds worth, then you won't see that happening. We could fix that in code, but it's actually fairly complicated to fix. It's a lot of lines of code for something that you should never run into in an official match. All right, that is autonomous in the books and teleop programming in the books. Our robot is programmed and ready to go. Our next step, we've got some tweaks. We know we weren't shooting necessarily quite high enough in autonomous mode, so we're going to look at what things you can tweak there. We've got to take this robot to an actual field and try to dial it in for how the field is set up. So that's the next video. We're going to come back, hopefully have some field elements and some real space to drive around in so we can fine-tune our robot. Until then, another special thanks to First and Argosy Foundation for making this all possible.